Let's look at what the question is asking first. So it's indicate whether the GFR will rise or fall in response to an increase in the following. So when you talk about whether GFR will rise or fall, another way to interpret that is whether or not we're going to increase filtration or we're going to decrease filtration. So whether or not our overall force is for filtration, favoring filtration, or whether it's opposing filtration. So an increase in the glomerular filtration pressure. And this should be pretty straightforward. If we increase the glomerular filtration pressure, we're going to increase GFR, okay? These two things are directly proportional. These are essentially the same things. That's the force for filtration, moving that plasma across the glomerulus and into the Bowman's capsule. The second one is if we increase the glomerular capillary hydrostatic pressure. And so we're going to dissect this a little bit further. So the glomerular capillary hydrostatic pressure is the pushing force that is existing in the glomerular capillaries. So that force will favor movement of fluid from the glomerular capillaries into the Bowman's capsule. And so that will also favor a rise in GFR. So if we increase our glomerular capillary hydrostatic pressure, we're going to increase our GFR. That will increase filtration. The third one is if we increase the glomerular capillary osmotic pressure. So this is now a pull force that is existing in the glomerular capillary. So this is going to be favoring the movement of fluid from the Bowman's capsule back into the glomerulus. And that will be opposing filtration. So if I'm increasing my glomerular capillary osmotic pressure, I am going to be opposing filtration, so I am going to decrease GFR. Okay, really, really important. Forces that oppose filtration will decrease GFR. Forces that favor filtration will increase GFR. The fourth one is if I increase the hydrostatic pressure in the Bowman's capsule. Again, we're thinking about this as a push force, but this time this is existing in the Bowman's capsule. And so if we're pushing fluid from the Bowman's capsule back into the glomerulus, we are opposing filtration. So if I increase my hydrostatic pressure in the Bowman's capsule, I am going to oppose filtration, therefore I'm going to decrease my GFR. Okay. And then the fifth one here is the concentration of proteins in the plasma. This should be very familiar to what we talked about in the cardiovascular system. So if I've got more proteins in the plasma, which is essentially in the blood, in the glomerulus, I'm going to increase my pull force from the glomerulus, from the Bowman's capsule back into the glomerulus, which is going to be opposing filtration, which is going to decrease GFR. So remember we said that osmotic pressure is a reflection of the presence of proteins. So increasing my protein concentration is essentially increasing my osmotic pressure. And then we want to look at where that is taking place. If it's happening in the plasma, it's obviously going to be in the glomerulus. And so it's going to be pulling fluid from the Bowman's capsule back into the glomerulus, which is opposing filtration. Okay, so I hope everyone got those right. I don't see anything popping up, but if you have a question, just throw it into the chat. Okay, the second question I won't go over because we talked about this as a part of that essay type response. And then question 3 is the control of afferent and efferent arteriolar resistance by renal sympathetic neurons an example of intrinsic control or extrinsic control? Why and how does an increase in sympathetic activity tend to affect GFR? Okay, and I'll go back to this to kind of answer that. So we talked about the involvement of the sympathetic nervous system as an extrinsic control. And in order to answer why, we know that anytime anything outside of the kidneys is influencing GFR, that is an extrinsic means of regulation. So we know that intrinsic mechanisms are the 3 that we talked about at the beginning of class. Extrinsic mechanisms are basically the sympathetic nervous system, so neurons or hormones. And then the third part of that question is how does an increase in sympathetic activity tend to affect GFR? So an increase in sympathetic activity is going to increase the resistance in both our afferent and efferent arterioles, as we described here earlier. That will increase resistance or decrease the radius of those vessels, which will decrease the amount of flow coming through the kidneys, the amount of fluid or plasma being filtered, which will essentially decrease our GFR, and that will bring about a decrease in urine output, okay? So a sympathetic response tends to decrease GFR,